everybody. Today we're going to be learning about section 8.3, which is on endocrine disruptors, and we're also going to be covering some information on industrial water pollutants. The learning objective for today is that you can describe endocrine disruptors and that you can describe the effects of endocrine disruptors. Some of the essential knowledge that you're going to gain is how endocrine disruptors are chemicals that can interfere with the endocrine system of animals and some of the consequences that they can lead to. We're also going to cover some essential knowledge about heavy metals and mercury when they are introduced into aquatic and terrestrial environments. So let's start with the basics of what is an endocrine disruptor. Endocrine disruptors are going to be chemicals that interfere with the endocrine system of animals, and the endocrine system is the hormonal system. Now, the way that they work is they bind to the cellular receptors that are meant for hormones, so they end up blocking the hormone from being received, or they amplify its effects. So if you look here in this diagram, this would be the receptor that you have in your cells. The green would be the endocrine disruptor, and then the hormones, when the endocrine disruptor comes in, they end up blocking it so that the hormone actually can't bind with the receptor, and then you are going to be having either totally blocking the hormone, or you'll be amplifying its effects because the hormones can't come in and stop things from happening. Now, human medications are going to be a really common form of endocrine disruptors. Think, for example, like birth control that many females take, and because they work on humans, they are also going to disrupt animals' systems. So that is going to be one that my cat's making an appearance in this video. Sorry. So let's look at an example. An example is going to be atrazine, which is an herbicide that is sprayed on crops in order to kill off weeds. What it does is it's going to bind to the receptors of cells that should convert estrogen into testosterone in male frogs. So it leads to the frogs having higher estrogen levels than they're supposed to. It also leads to a low sperm count, and it can even lead to feminization, which is where you have actual ovaries being developed in male frogs where they should have testes. And so if you look at this diagram here, this frog has both ovaries and testes because the endocrine disruptors have made it so that there's too much estrogen in their system. Now we're going to look at some very common endocrine disruptors, what they are, where they come from, and then some of the effects that they can have. So the first one, which I just mentioned, is atrazine. And as I said, it's an herbicide. So it's a broad spectrum, which means you just spray it on all the crops in order to control the weeds and to prevent crop loss. So this is going to be applied in agricultural fields, and you're going to get it entering aquatic ecosystems because it runs off into local surface or groundwater, or it can be carried by the wind. So also on terrestrial ecosystems as well. Now, it also has the ability to contaminate human well water or even enter the body via unwashed produce. So I know that I talked about like frogs and other animals, but humans can also be impacted by these endocrine disruptors, which can mess with our systems because we have hormones. Now, another example is going to be DDT. This was a broad spectrum insecticide that was phased out because we found out it had a lot of consequences, but it still persists in the environment, even though we aren't spraying it anymore here in the United States. But it was applied to agricultural fields, and again, it would run off into local surface or groundwater, or it was able to be carried by the wind. Then we have phthalates, and phthalates are going to be compounds that are used in plastic and cosmetic manufacturing. They can enter the surface and the groundwater via improperly disposed of waste and also landfill leaching. So even if it's thrown away, you can have that leach out into the groundwater in the area. And phthalates are also found in some cosmetics and plastic food containers. Fun fact, if you look on the back of the ingredients list and you see fragrance, which what does that even mean? But fragrance sometimes has phthalates in it. So the things that you tend to put on your body, like lotions and cosmetics and all of that, can actually contain these phthalates that are endocrine disruptors. Now, additionally, endocrine disruptors can be heavy metals like lead, arsenic, or mercury. And then many human medications, again, I mentioned birth control as an example, and those can enter sewage via human urine. So even as it passes through the body, the excess is urinated out, so that ends up in the sewage. Or even people will improperly dispose of their meds by flushing them. Don't ever do that. This is my PSA. There are safe ways to dispose of medications. Don't throw them away. Don't flush them, because this is how we end up with endocrine disruptors getting out into the environment. So we're going to look at some of those heavy metals, and we're going to specifically start with looking at mercury. Mercury is actually naturally occurring in coal, and it is released by anthropogenic, so like human-caused activities. Things like coal combustion, trash incineration, burning of medical waste, heating limestone for cement, all of this is going to be releasing mercury. Now, the mercury is going to attach the particulate matter as it's being burned, and then this particulate matter can get deposited in soil and water, and the mercury is going to be carried with it. It also can be released if the coal ash, so the extra ash from burning that coal, if it's stored in ponds or like containment areas, that can be flushed out if you get overflow or you get flooding or runoff, and so mercury can be introduced that way. Now, as I said earlier, mercury is an endocrine disruptor, and this is because it inhibits estrogen. It also messes with insulin as well, but when it inhibits estrogen, this is going to interfere with the menstrual cycle and ovulation. Then we also have teratogen, and that's a chemical that's harmful to developing fetuses and can accumulate in a fetus brain. So pregnant women need to decrease their chance of mercury. Mercury can be high in fish because it accumulates as you go up the food web. And so pregnant women need to be really careful about the type of seafood that they are eating, because if you get mercury levels that are too high when you're pregnant, it can cause harm to the developing fetus. So this is going to kind of show how mercury can cycle through. It's emitted into the atmosphere, it gets deposited, and then it's going to accumulate. And then as it accumulates, it's going to end up in food webs, which then can be passed on to us or to other predators in the food web. And not only do we get it like building up in aquatic food webs, you also get it like in little bugs, and it can build up in birds as well. And so it can end up in aquatic ecosystems or also terrestrial ecosystems. But again, it's mostly going to be this like industrial release from coal. Now, arsenic and lead. Arsenic it's a naturally occurring element. It's found in rocks underground, and it can dissolve into groundwater, and mining is something that can actually worsen the release of arsenic. Now, so anthropogenic sources, so human-caused sources. Arsenic was also formerly in pesticides and was applied to agricultural fields, which means it can still be in the soil. It can be lingering from previous like coal combustion and ash. And so you can have arsenic still sticking around for a very long time. Fun fact, Tacoma actually had a industrial plant that released a lot of arsenic, and it was near like Point Ruston. And so if you have a home in North Tacoma, which I do, your soil actually has arsenic. So I need to be careful. Like I wear a mask when I do heavy gardening and I'm kicking up dust because there's arsenic in my soil, and I have to make sure that I'm not ingesting that. So the reason I don't want to ingest that is because arsenic is a carcinogen, so it can cause cancer, and it's also an endocrine disruptor. Now, one of the things that you can do with arsenic, especially if it gets into water, is you can use water filters in order to actually remove this. So that's something that people will do. Now, lead is going to be, as we previously talked about with lead, it's found in old paint in homes. It's been phased out of paint, but old homes have it. It also is in old water pipes. Water pipes used to be made of lead. And then it's also in soils that are contaminated by particulate matter from vehicle exhaust, because before the 70s, we had lead in our gasoline. And so as that exhaust was going out and the particulate matter was settling with the lead, it can still be in the soil, even now, even though it was phased out decades ago. It's also released in fly ash, which is the particulate matter that's coming out of coal combustion. And the problem with lead is that it's a neurotoxicant, so it can damage the central nervous system, especially in children who have sensitive brains that are in the middle of developing. And it is also an endocrine disruptor, as all the things we're talking about in these notes. And lead is one that can be filtered out with water filters. So If people know that they have an old home with lead pipes, then it's really expensive to get it all replaced. So sometimes it's a lot easier to just have a water filter on it. I rented an old house and we had a water filter on it that just filtered out the lead to make sure that we weren't ingesting any of it. And this image is just kind of giving you a visual of all of the particulate matter and things that can be coming out of this coal combustion. And this right here is what it can look like, old lead pipes. And you can even see sometimes people will meet them up with new copper pipes, but as long as you've got that old lead pipe, it can be leaching lead into the water that you're drinking. So now we're going to talk about coal ash. And coal ash is, again, going to be the ash that is released when coal is being combusted. And it can be a source of mercury, lead, and arsenic. So it can attach to the fly ash, that ash that's coming out, or the heavy metals can attach to this ash that's coming out of the smokestacks. And then it can be carried far away by the wind, and so it can actually be deposited in ecosystems that are not necessarily right next to these facilities. You can also have the fact that we store our coal ash and we store it in sites in like ponds. We dig it into the soil. We kind of have like these areas, which you can see in this picture here. And ponds can leach into groundwater. You can also have runoff and flooding where it can be overflowing into nearby surface waters and also agricultural fields. And so that's something that's always going to be a problem with these just stored ponds, and it's a risk. Now, if you look at this example here, for example, if this is our coal ash pond where they're storing the extra coal ash, it can be leaching into groundwater, which is where people get their water from. It can be getting into crops. It can also be running off into surface area, which will lead to death of the organisms that live there. So this is going to be your practice FRQ for 8.3. I want you to practice the suggested skill of describing an environmental concept or process. So for your practice FRQ, I want you to identify a toxic metal other than mercury that has a negative effect on human health and describe how it is introduced into the environment. So that's going to be your practice FRQ for 8.3, and those were your notes on 8.3 on endocrine disruptors.